Okay, so volcanism refers to the movement of magma is cooling above or beneath the surface and the plutonic intrusive and extrusive rock formation created. So there are three materials injected during the volcanic eruption. There are the gases, pyroclastic material, and the lava flows. Okay, so for the lava flows, there are three distinct types of magma, which are the basaltic magma, andesitic magma, and the rhyolitic magma. So these three are different in silicon content, and different magma can lead to different form of eruption and volcanic landform. The basaltic magma, andesitic magma, and the rhyolitic magma has 50%, 60%, and 70% of silicon content respectively. Okay, so for the main difference between the basaltic magma and the other two are the basaltic magma, it has a low viscosity and it requires a long time to cool and solidify, while the other two, it has high viscosity and it can be cool and solidified in a short basaltic magma is more frequent but is gentle due to the release of gas, while the other two happen less frequently but is more violent due to the build-up of gases. So approximately there are about 80% of magma erupted by the volcanoes is basaltic, while the other two takes up about 10% each. Okay, then there are three types of lava flows, which is the Pahoho flow, R flow, and the pillow lava. So there are these three are all originate from the extrusion of basaltic magma, but pillow lava is formed when it is extruded underwater, such as along the mid-ocean. Okay, so the surface of Pahoho flow is usually twisted and generally thin, but the surface of R flow consists of a jumbled mass of angular blocks, which forms when the congealed crust is broken by slowly moving flow. Pahoho flows form at the initial stage of eruption, while R flows forms later when the viscosity increases and the rates of movement slows. Okay, so the pillow structure forms when the surface of the basaltic lava chilled and the brittle surface crack and the magma oozes out and the process continues. So most of the lava on the oceanic crust are pillow lava. Actually, another fact about lava flow is that most of the lava on the ocean do not move that fast. Instead, because they are fluid, thus they follow existing low areas, and it's actually easy to predict the path that the lava will flow and give time for evacuation. Okay, so the pyroclastic materials form when there is a build-up in internal pressure and produce a violent eruption. So the ejected lava fragment range in size from bombs to lapilli and to ash. Bombs and blocks are particles with more than 64 mm in diameters. So due to the large size, they are unable to be as widespread as ash did, and they are near the eruption point. So lapilli has a diameter between 2 to 64 millimeters, and for the ash, it's less than 2 millimeter in diameter, and there are two types, which are the ash flow and the ash fall. So for the ash fall, it happens when ash is ejected into the atmosphere and is settled to the surface over a large area. For the ash flow, which is a coherent clouds of ash and gas that commonly flow along or close to the land surface. So the laha is a type of mud flow when volcanic ash becomes saturated with water and flows down steep volcanic slopes, generally flowing the stream valleys. So it made up a significant proportion of composite volcanoes. So magma contains various amounts of dissolved gas and is believed to compose 1 to 5% of the gas total weight. Gases emitted contain 70% of water vapor, 15% of carbon dioxide, 5% each of nitrogen and sulfur compound, and lesser amount of chlorine, hydrogen, and so the viscosity of magma, which is controlled by the composition, temperature, and amount of dissolved gas in content. As the temperature increased, the viscosity lower and more readily magma flows. So as the lava cools, it begins to congeal and the mobility decrease. This contributes to the lava flow from Pahoho flow to the R flow. So for the composition, the higher the percentage of silicon in the magma, the greater the viscosity, and thus the basaltic magma has a higher viscosity than the andesitic magma and the rhyolitic magma. It can travel up to 150 km or more, while the rhyolitic magma tend to form comparatively short thick flow. So lastly, the gas content affect the mobility, as dissolved gas tend to increase the fluidity of the magma. So the viscosity of magma has linked with the nature of eruption and the amount of pyroclastic materials, as both of these depends on the viscosity of the magma. The higher the pressure, the more the amount of gas magma can dissolve. Very fluid basaltic magma allows expanding gas to escape, thus the eruption is not so aggressive. However, for the other two types of magma, it impedes the upward migration of gases and forms explosive eruption. The difference between non-explosive and explosive eruption are therefore largely a function of magma viscosity and dissolved gas content. When little or no dissolved gas is present, magma will be erupted as a lava flow regardless of composition. Okay, so next I will talk about the type of volcano eruption and landform. Shell volcanoes are built primarily by basaltic lava, which is non-explosive and contains a small percentage of pyroclastic materials. Its broad, slightly domed structure and the basaltic lava is capable of flowing great distance with thin sheets of 21 thickness. So shell volcanoes are most common in oceanic areas such as the Hawaii Island and Iceland. Okay, so another type of volcano with basaltic lava is the basalt plateau with pressure eruption. Due to the nature of lava, it is able to flow as long as 150 km from its source. So this volcano, it has abrupt edges at the sides, and lava flows have dormantly vertical joints. Example will be the first fissure eruption at Laki in Iceland in 1783. Next, the composite volcanoes are produced when viscous lavas of andesitic composition are extruded, and it is the most violent type of volcanic activity. It may extrude viscous lava for a long period of time, then suddenly change the style of eruption and eject pyroclastic materials. It is unexpected, thus is more devastating. Composite volcanoes are large and symmetrical with inner-bed lavas and pyroclastic deposits. Lava is present in composite volcanoes as well. It has steep slope and the typical large volcanoes of the continent and island arc. Molten Mayon in Philippines and Fujiyami in Japan are some classic examples of composite volcanoes. Cinder cones form when the pyroclastic material is injected into the atmosphere. They are rather small, which is less than 300 meters, and form parasite cones. Example will be in southern Rocky Mountain states, particularly New Mexico and Arizona. Lastly, the calderas are formed when the summits of a volcano structure collapse into the partially empty magma chamber. Eruption produce the cinder cones called Wizard Island. Rainfall and groundwater contribute to form the lake. Okay, so next I will talk about the distribution of volcanoes. So most volcanic activity coincides with the active seismic regions of the world and is clearly associated with the plate boundaries, and the types of volcanic activity depends on the plate boundaries. Thus, most of the volcanoes they are located near the plate boundaries. Okay, so there are two major volcanic belts. One of them is called the Circum-Pacific Belt, which contains about 60% of the world's active volcanoes, and which include volcanoes along the west coast of South America. And then the other belt is the Mediterranean Belt, which contains about 20% of the world's active volcanoes, which include famous Italian volcanoes such as the Mount Etna. And most of these volcanoes are composite volcanoes, which are composed primarily of mafic lavas. And for the rest of the volcanoes, they are located along the mid-ocean ridges. The longest of these ridges is the Mid-Atlantic Ridge, which is near the middle of the Atlantic Ocean basin. Most of the volcanism along the Mid-Oceanic Ridge is submarine, and much of it goes to be undetected. So the volcanism at hotspots are some volcanoes occur in the mid of tectonic plates, where hotspots are found, and most of these are in the Pacific. And with this, I have come to the end of the topic volcanism. Thank you.